Hello guys, and welcome back to the reaction zone. Now in today's lesson we're going to look at how to solve the question on electrolysis on the board. And the question is as follows. How long will a current of 3 amperes be applied through a solution of silver nitrate to coat a metal surface of 80 centimeters squared, that is 0.005 millimeter thick, given that the density of silver is 10.5 grams per cm cube and atomic mass of silver is 108. So, to solve this question, the first thing to do is to itemize the parameters that we have in the question. So, according to this question, we are given a current of 3 amperes, and then we are given the area of a metal surface to be 80 centimeters squared, and we are given the thickness to be 0.005 millimeters, and then we are given density to be 10.5 grams per centimeter cube. Now, the question is telling us to find the time. It's telling us to find the time. Now, if you look at the formula that we're going to need to solve this problem, which is N is equal to MIT over NF. If we make time the subject, it is going to become MNF over MI. Now, the current is given. We know the atomic mass to be 108 according to the question. We can find the value of N. We know the value of F, but we don't know the mass of silver. And it is impossible for us to find time without knowing the mass. So what this means is that the first thing we have to do is to find the value of M. That is the mass of silver that is deposited. Only then can we now find the time. However, we have some parameters in the question that can help us to find the mass. Now, if we look at this question, we are given density. And let us recall that density is equal to mass over volume. So, which means that mass is going to be volume multiplied by density. Now, the value of density is given, but we don't know what the volume is. But we can recall that volume is equal to area multiplied by thickness. And according to this question, we have the thickness to be 0.005 millimeters, and we have the area to be 8 centimeters squared. Now, their units are not the same. Density is in grams per cm cube, area is in centimeters squared, but thickness is in millimeters. So we have to convert this to centimeters. Now, if we convert 0.005 millimeters to centimeters, it's simply going to become 0.005 divided by 10, because 10 millimeters gives us 1 centimeter. So, it means that the volume in this case is going to be the area, which is 80 centimeters squared multiplied by the thickness. Now, 0.005 divided by 10 is going to become 0.0005 centimeters. Now, this is going to be the volume. Now, we can now find the mass, because we know that volume now is 80 centimeters squared times 0.0005 centimeters multiplied by the density. And the density is 10.5 grams per cm cube. Now when you multiply this, it's going to give us 0.4 grams. So it means that the mass of silver is 0.4 grams. Now that we know the mass of silver, we can now find how long it is going to take to coat a metal surface of 80 cm squared that is 0.005 milliliters thick. Now, using this expression here, our time is going to become small letter m, which is mass of silver is 0.4, multiplied by n. Now, how do we get n? Let us not forget that silver is a univalent positive ion, which means it is going to lose an electron to give silver atom. So the charge on silver ion is +1. So it means that n is equal to 1. So T is going to be 0.4 times 1. 1 is the value of n. Then F is 96,500 divided by capital N here represents the atomic mass of silver. And the atomic mass of silver, according to the question, is 808. So that is 108 multiplied by the current. Current is 3. And that is this. And when this is solved, it's going to give us a value of 125.09 seconds. So what this means is that the time it is going to take for a current of 3 amperes that is applied to a solution of silver nitrates to coat a metal surface that is 80 centimeters squared and 0.005 millimeter thick. The time it's going to take for it to coat that metal surface is going to be 125.09 seconds. I want to believe that the explanation to this question is clear. Thank you very much and see you in the next lesson.